Hi guys, so today we are going to solve some questions from the topic Fundamental Principle of Selection. Let's start with the first question. A committee of 5 members is to be formed out of 5 math faculty members, 4 verbal faculty members and 10 students. In how many ways can the committee be formed? The committee should contain at least 3 math faculty members. Now we need at least 3 math faculty members. At least 3 has some significance. So at least 3 means minimum 3 and the maximum members could be 5. So at least 3 math means we need 3 math and the other 2 members could be from verbal and student. This is the first possibility. Second possibility is we need 4 math and the remaining one is anyone out of verbal and student. And the last possibility is we can take all the 5 math faculties. Now, these are the possibilities. So let's try to select the members now. 3 math, it is going to be 5C3 because 3 math out of 5. 2 members out of verbal and students, so 14C2. 4 math, so it is going to be 5C4. Out of 14, 1 member is selected, so 14C1. 5C5 because all the 5 members are selected. And 14C0, that is 1. Now, wherever there's and, I'll write multiplication. Wherever there's odd, I'll write wherever there's or, I'll write plus. Solving this will give me the final answer. That is 981. Moving to the next question. The question remains same. The information remains same. The question is different. In how many ways can the committee be formed if the committee should contain exactly 2 students, at least 1 math faculty, at least 1 verbal faculty? So the students part is fixed. We need exactly 2 students, but we have to think about the remaining 3 members. As the condition says, at least 1 math and at least 1 verbal. So we have to take the possibilities now. First possibility would be to take 2 students, 1 math, 2 verbal, or 2 students, 2 math, 1 verbal. Because it's at least 1 math, at least 1 verbal. So it can be 1 math or 2 math. Similarly, 1 verbal or 2 verbal. Now we just have to make the selection. So 10C2, 5C1, 4C2, 10C2, 5C2, and 4C1. Wherever there's and, I'll add multiplication. I'll do multiplication. Wherever there's or, I'll do addition. Solving will give us the answer as 3150. That is option 3. Moving to the next question. A basket contains 5 mangoes, 8 oranges, and 10 apples. Find the number of ways of selecting fruits from this basket. 5 mangoes, 8 oranges, and 10 apples. So the number of possibilities of 5 mangoes would be I'll select 0 mangoes, then I'll select 1, then 2, then 3, then 4, then 5. Similarly goes for 8. Similarly goes for 10 apples. So 5 mangoes, for 5 mangoes, I can have 2 raised to 5. For 8 oranges, I can have 2 raised to 8. For 10 apples, I can have 2 raised to 10. It's a compulsion of selecting all the 3 categories. Whenever it's a compulsion, we have to do multiplication. So this will give us 2 raised to 23. So 2 raised to 23 is the answer. Moving to the next question. A basket contains 5 mangoes, 8 oranges, 10 apples. Find the number of ways of selecting at least one fruit from this basket. So we have to select minimum one fruit. That means if we are selecting minimum one fruit, we will not consider the possibility. The concept will remain the same as the previous question, but there's just one additional thing. So that is over here we also have considered the possibility of zero. Zero means of selecting no fruits. In the question, it says we have to select at least one fruit. If we have to select at least one fruit, we will not even look at the possibility of 0. Hence, we'll eliminate one possibility of 0. So, it is going to be 2 raised to 23 minus 1, which is option 1. Moving to the next question. A basket contains 5 mangoes, 8 oranges, and 10 apples. Find the number of ways of selecting at least one fruit of each type from the basket. Now, it says we have to select at least one fruit of each type from this basket. That means the concept will remain same, but as we need to select at least one fruit from each basket, we will subtract 1. That is, we will subtract the possibility of 0 from each of the category. So, 2 raised to 5 minus 1, 2 raised to 8 minus 1, 2 raised to 10 minus 1. That is, option 2 is the answer. Moving to the next question. A basket contains 5 identical mangoes, 8 identical oranges, 10 identical apples. Find the number of ways of selecting fruits from this basket. Now, we need to select the fruits. Also, we know that the fruits are identical now. So, as the fruits are identical, in how many ways can we select 5 mangoes? We can select it in 6 ways. 0, 1, 2, 3, 4, 5. In how many ways can we select 8 oranges? Again, 9 ways. In how many ways can we select 10 apples? Again, 11 ways. So 6 into 9 into 11, that's 594. So 594 ways, that is option 3 is the answer. Moving to the next question. Find the number of ways of selecting at least one fruit from this basket. Now, we need to select at least one fruit from this basket. Again, as we need to select at least one fruit from this basket, we will have to eliminate the possibility of 0. We will simply do minus 1 to it. So 594 minus 1, that is 593, which is option 3 is the answer. Moving to the next question. Find the number of ways of selecting at least from each type of basket. So over here, we have to eliminate the possibility of 0 from each of the baskets. So it is going to be 6 ways minus 1. We are eliminating 0's possibility from each type of basket. So minus 1. 9 ways minus 1. And 11 ways minus 1. 5 into 8 into 10. That's 400 ways. Option 4 is the answer. Moving to the next question. 5 sockets are available which are aligned in a row. There are white and black plugs which are to be placed in the sockets. Only one plug fits into a socket and the plugs are of same color, and plugs of the same color are indistinguishable. Two black plugs cannot be placed in adjacent sockets. In how many color combinations can the plugs be placed in the sockets? So there are 5 sockets available. Now there are 5 whites. This is the one way. We know one condition, that two black plugs cannot be together. So all the plugs can be white. This is one possibility. So if all the plugs are whites, we can have one possibility. If 4 are whites and 1 is black, we can have 5 different ways, plus 5. If two are blacks and 3 are whites, we can have the ways in this way. That is, there must be 3 whites in between, and we need to put 2 blacks. As this is the only case of putting 2 blacks, because the blacks are not together. We have to select 2 blacks out of 4 empty spaces. So it is going to be done by using 4C2 ways. So that is 6 ways. Now, next is three blacks and two whites. That is only one way, because I can't select any other thing, because they are already selected and they are already placed. So black, white, black. This is the only one way that we can select it. Now, four blacks, one white is not possible because two blacks must not be adjacent. Hence, this is the final answer. That is 1 plus 5 plus 6 plus 1. That is 30, which is option 4. Moving to